let us start. So this is the outline of the talk. So first I'll give the introduction to the TensorFlow Developer Certificate. What is this exam all about, and what it expects from a aspirant to have, and what are the examination rules. I'll broadly say how what all examination rules a TensorFlow Developer Certificate has, and what all prerequisite needed in order to clear this exam. And I'll also be discussing about how do we prepare for this exam, and more specifically about some few aspects which we need to be little careful, because more or less everything, if we have a little background of ML or neural networks, we would be able to understand, but there are few things which we need to remember so that we don't fall into that pit. So, and how should we attempt the exam on the day of exam, and what is my experience of this TensorFlow Developer Certificate exam, and how the result would be, and some important links which we need to save so that it will help us to get more information about this exam. So I'll start with the introduction to TensorFlow Developer Certificate. So yeah, I'll put in the slideshow mode. If there is anything to be discussed or any issues, do let me know. So TensorFlow exam, developer certificate exam, checks the aspirant's ability to build TensorFlow to develop deep learning models. Although the manual says that it tests machine learning and deep learning, but we know that machine learning includes a huge set of algorithms, and the neural networks is just a subset of machine learning, and deep learning is a further subset of neural networks. So this particular certification mostly, although it says machine learning, but it mostly focus on developing or deploying how do we develop or how do we build deep learning models. So I have listed out what all tasks which we would like to achieve, and what all different types of deep learning models which we are interested in. So in deep learning there are various types of models. So we have a simple feed forward neural network, we have a convolutional neural network, we have a recurrent neural network. Within the recurrent neural network you have LSTMs, GRUs, gated recurrent units. There are various other neural networks, but this particular exam focuses on a broadly, you can say, three different types of neural networks. One is a fully connected neural network, and convolutional neural networks, and recurrent neural networks. Within recurrent neural networks, more particularly LSTMs, GRUs, gated recurrent units. So these are I've listed out here what all things, or what all deep learning tasks, or what all tasks which we would like to achieve, and what all deep learning models we usually use for so and so task. First, the exam, or even our preparation should start with this basic prediction, where we simply use a fully connected neural network and try to predict housing prices. And we have tasks like image classification, and there are various issues like overfitting, and there are methods to solve those overfitting things. So we should be aware of that. There are very famous technique called as transfer learning. We need to know the theoretical concept of transfer learning and how do we implement that. And within NLP there are various concepts like tokenization, and various layers like embedding layer, and various neural networks like LSTMs, so in order to predict the next words. So there are various concepts within NLP, so we should focus on that. And we also have time series prediction, where we once again use LSTMs. So these are the broadly the set of tasks which we have, and set of neural networks which we are interested to learn and to master, so that we can easily clear this exam. So this is a broad overview, but I'll be giving more details about how at which stage you will encounter these, and what all things we need to remember at each stage. So I'll go into more details as we move along. So first I want to discuss about this exam, TensorFlow developer exam. It's a 5-hour exam. So 5-hour exam with 5 questions, and each question has a model to be saved and uploaded. So if you don't upload any, and if you don't submit any model, it after 5 hours it goes into auto submission. So whatever models you have developed until that point of time, it will evaluate and it will give you the score. And it is an unproctored open book exam and open internet exam. You can use any of the books, materials, you can use internet search, you can search internet, you can find solutions, you can use Stack Overflow solutions, anything is allowed. And more importantly, I'll be discussing in more detail, there are few manuals which we need to follow in order to set up our environment, but there are certain things which are obsolete in the manuals, which we need to be real careful, especially the PyCharm version which we need to install and the TensorFlow plugin which we need to install are wrongly depicted. So maybe so I'll show it to you how where it is wrongly mentioned, and these are the latest versions 2022.2 and 2022, within that 0.1.16. We will obviously come to know when our the version which is mentioned in the manual doesn't work, we automatically end up to these new versions. So this is a PyCharm new version and the TensorFlow plugin new version, so that we need to set up. And so usually this exam does not ask you to write the code from the scratch. There will already be a set of code in every question. So there are 5 questions. In each of these questions there will be a base code which is already available. Certain blank lines would or kept so that we write our own code and build our own model. But in every question you will be developing a deep learning model. And towards the end there will be a model.save command which saves automatically. You don't need to do that. So you don't even need to know that. You just need to know how to build the model. How do we choose the hyperparameters carefully so that our architecture what we design achieves the efficiency what we decide in the fewer number of epochs and in the way the question is asked. So we should achieve the task in as per the question. So we should be careful about how do we should be careful about achieving the desired results within the minimum architecture without any computational overload. So that is what we generally the all the 5 questions are about. And so this exam has a cost of $100 for one exam attempt. And if once you purchase this exam, you can write the exam anytime for the next 6 months. So but once you have written the exam, and if at all if you have failed to clear the exam, you can write a second attempt after 14 days. And if at all if you don't clear it within the second attempt, you can give a third attempt after 2 months and fourth attempt after 1 year. So and this certification, once if at all if you successfully clear this certification, it will be valid for 3 years. And after 3 years you need to rewrite the exam in order for you to say that you are certified in the TensorFlow developer, as a certified as a TensorFlow developer. So these are broadly the steps which are involved. First and foremost, you need to read this candidate handbook, which gives all the things which are even the syllabus. It mentions the syllabus also line by line what we need to prepare. And the very it's a coincidence, or maybe it has been very carefully designed. There is a Coursera specialization course which exactly contains the syllabus of the TensorFlow developer certificate exam. So you can see a line by line matching between this Coursera course specialization, not just a course, because it contains 4 courses, and the handbook, the syllabus which is mentioned in the handbook has a one-to-one correspondence. So it's very important to do this specialization before we attempt the exam. And once we have completed, I have a complete set of materials which you need to follow to prepare for this exam. Not only this TensorFlow specialization, but there are other things also in order to make yourself thoroughly confident for this exam. So once you are confident with the exam, you need to register for the exam. It will ask for a passport and some credentials, and you have to use one of the mail ID. More often we would like to use our own, we should maybe use our own KLH mail ID in order to register for this exam. And so once you prepare for this exam, there are a set of links where you can attempt the exam. I have listed out in the next slide. And once we submit the exam, it will, within the few minutes we will come to know whether we have passed or not. We will get a mail, and towards the end we will get a certificate, and you can also join the community. All these steps I'll list out. I have few more slides to describe that. So before we go into how to prepare for this exam, we need to know what all prerequisite any aspirant should have, so that he or she can attempt preparing and also clear the exam. So first, basic understanding of Python, not at a proficient level, beginner to moderate level, because most of the code is already there in the exam. So the specialization is also designed in a way where you don't need to write the code from the scratch. You will be filling the blanks. So it expects only your understanding about the neural networks, how confident, how well you can design the architecture. They don't want to test you how good you are in Python. But certain things we should have a moderate level of Python expertise, so that we could clear the errors, bugs easily, so that we don't lose a lot of time. We should be able to create a virtual environment, which is clearly, these are all not within the exam, these are outside the exam. Before you start the exam, you should do few things, which I'll mention once again, like creating virtual environment, installing package, installing plugin, installing the right version of PyCharm, right version of TensorFlow plugin, right version of Python, right version of TensorFlow. So all these things we have to do, and the candidate handbook and setting up environment. There are two files which are mentioned which are given in the TensorFlow website, which will help us in doing it. But there are few things which are mistakes. I'll also highlight those, so that you don't fall into the same pit once again. So a basic understanding of classes and objects, nothing, no proficiency is needed. Maybe one or two, like some concept of inheritance, if you are fairly know it, it is more than enough. And how to access methods from objects, if you know it, that is more than sufficient. And a basic theoretical understanding of what is neural network and its terminologies, like activation function or a loss function, or what kind of optimizers you have, what is an epoch, what is batch size, all this terminology, what does it mean, what is neural network doing, all those things we should have an understanding. And basic theoretical understanding of CNNs, LSTM. LSTM, we don't even need a very thorough understanding. If we at all, if we just see an overview of how the architecture is, and in CNNs, if we know what is a kernel, what is the size of the kernel, what is kernel doing, all those things, some basic theoretical concepts of CNN is more than sufficient. And we have you should be able to know how to see the dimensions of a particular array or a particular tensor, and how to access different methods which are part of NumPy and TensorFlow. So you will be needing quite often when you are working with the deep learning models. So how to prepare for this exam? So as I was saying earlier, this specialization which is there in the Coursera, deeplearning.ai, from Lawrence, it is a perfect starting point for preparing. And as I was saying earlier, the whole of this course specialization contains 4 courses, and each course contains 4 assignments, 4 weeks of assignments. And they don't expect you to write the code from the scratch, they expect you to fill the blanks and complete the code. So the exam, the TensorFlow developer certificate exam, is exactly similar to how you write the assignments in this Coursera course. So this is a link for this course. So it contains 4 courses, and each course contains 4 assignments. I'll be discussing on in each course, each assignment, what all they ask. I have listed out. And in order to this particular Coursera course doesn't give any theoretical depth. It does not mention, give you a foundation, or explains about neural network or deep learning more thoroughly. It only explains about how do you build the neural networks in TensorFlow. So in order for you to get theoretical concepts, there are Andrew Ng lectures, those are anyway there, but if you want to have a solid book, this hands-on machine learning with scikit-learn, there are very especially from chapter 10 to chapter 16, it is very much relevant to the exam, with TensorFlow developer exam. And there is this tutorial from a person who has listed out all the important concepts to clear the TensorFlow developer exam. And there are, for advanced learning, there are, TensorFlow itself contains a lot of tutorial and images for image classification, object detection. You have complete code within the TensorFlow TensorFlow link web page. And there is also a course on sequence models by Andrew Ng, which gives a solid foundation, because sequence models are used in both the third and fourth courses in Coursera specialization, and it is also very much useful in the exam also. So yeah, this is the whole outline of all the courses, 4 courses which are part of the TensorFlow specialization. So in the week 1, you will be working on the housing price prediction, simple prediction problem, simple one layer, 1 unit neural network with no activation. So if you don't use any activation, by default it is a linear activation. So since it's a linear activation, it's like a regression problem. So it predicts a value. So it's, you build this as the first one, and in fact the 5 questions which you ask, some of the problems are very easy. The first 2 questions are very easy. Usually they take from one of these, so they don't cross even these 4 courses. So most of the problems which they ask in the TensorFlow developer exam are part of this specialization. So what I saw is, when I was writing the exam, they might have solved one problem with a certain data set. So they'll try to swap the data set and the problem. So they just modify that and they try to ask the question. So you might have used the data set for a certain other problem. In the exam, they might ask for a certain other problem. So, but more or less, they use the same kind of data set, same kind of for the questions, everything mentioned in this specialization. So it is very important to do this specialization. So in the week 1, so we do a simple prediction problem. And in week 2, we will get introduced to the callbacks, and that is where we first get introduced to the callbacks class. So tf.keras.callbacks, we have a callbacks class which we inherit, and we create a callback. So we don't even need to, when we do this course, the ungraded assignments which are being taught explains clearly about that. So it is very important to go through that videos and then do the assignment towards the end of the course. So we have MNIST with convolutions, where we first introduced to this two-dimensional convolutional CNNs. So definitely dense neural networks, CNNs outperform dense neural networks. It is CNNs were neural networks were there from 1970s, but CNNs were only introduced in 2012. So they are basically translation invariant. Whether the image is shifted or rotated, it doesn't matter, because it try to find out the kernels more efficiently, so that even if they are translation invariant, it is able to classify it. So it's the task. So usually in a neural network we learn the weights, but in convolutional neural network we learn even the kernels, 3x3 kernels, which are very important during classification. So this third week is about convolutional. Implementation of convolutional neural network in TensorFlow is very easy. We have this command called as conv2d, and I have few examples. I'll try to show it. There are some max pooling layers. So we don't need to understand the complete convolutional neural network, but we need to know whatever commands we use, especially conv 2D. What is it doing? What are the parameters? What is the meaning of that parameters? Max pooling 2D. What is max pooling and what are the parameters? So if we just understand these things, we would be able to clear the Coursera course and also the say exam. So it doesn't test you the depth of convolution, theoretical depth of convolution. It only tests whether are you able to implement the convolutional neural network, and are you able to carefully choose the hyperparameters without increasing the complexity and reaching to the efficiency what is desired. That is what it tests on. So, and the week 4 is also once again convolutional neural network, but here you will so here you will work on a different data sets like happy and sad data set. And so this whole course 2 is about convolutional data neural network, but here you will be learning two or three important concepts. So apart from learning the convolutional neural network concepts on some standard data set, you will be knowing how to develop the data set from the scratch. So usually what happens is Keras has built-in data sets like MNIST data set or fashion MNIST data set. You don't build anything, you just invoke that command, so you get all the testing trained labels, test labels into a variables, and you just give it to the model, you train the model. But if at all, if you have been given a data set completely from the scratch with only cats and dogs images, how do you build the directories? How do you create the directories? And there is a training directory, there is a validation directory, training labels, validation labels, test directory, test labels. So there is an automatic process. You don't need to do manually, but there is an automatic process to do it, which is part of image data generator, which you will study in course 2. And there is methods like flow from directory. It automatically creates that. It saves us a lot of time, and you can carefully tweak with different sizes. Sometimes you can use 80-20 or 80% training and 20% validation, or 70-30. You can quickly change it. You don't need to manually change the images from one folder to other folder. So such kind of convenience is there with image data generator, which you will study, which you will learn in course 2. And the important concept is overfitting, and there are two different ways of avoiding overfitting. One is using dropouts. So dropout is a simple concept of randomly avoiding few neural links, and the people have found that by randomly eliminating few of the links between the nodes, it achieves a better efficiency. And that is one way of avoiding overfitting. And there are second way of avoiding overfitting is to increase the data set, and the image data generator allows you to kind of increases. Suppose if you have a very small data set where you have only 100 images and 100 images for two classes. Suppose if you want to have say 10,000 images, so you take an image and you rotate that image and it becomes a new training image. So there are various operations which you can do on each images, like sharing, rotating, zooming, and taking a part of the clipping, all these flipping, all these different ways of modifying each image. You can get a much larger data set. So you are having a small data set, but you are enhancing the data set by doing all these operations and we are not doing manually, or we are not writing a code to do that. We have an image data generator, so which does automatically. So it increases the data set, thereby it avoids the overfitting, and it also works when we have a small number of data set. So that part is learned in convolutional neural network. And then comes the transfer learning. Transfer learning is one of the very important and concept, because once again when we have a small data set, usually our whole of the deep learning needs a huge set of data set, and most of the times we creating the data set is the biggest challenge. But most of the applications which we work on are most of the models we work on a similar thing. For example, someone has created a face recognition data set and he trained a model for various faces. You can use that already pre-trained model and just run on the few set of examples which you have, so that that whole model becomes like what you desire. So you are not you, so since you don't have a huge data set, what you are doing is already pre-trained models. Something like Microsoft has ResNet, or there are Lenet, Google Net, ImageNet. There are various neural networks, deep neural networks, which have been trained by these multinational companies. So there is a way to just use those neural network for your purpose, and you might be having a small data set, and you train the data set, you train the model with your limited data set, so it modifies the last few layers, and it gets adapted to your needs. So transfer learning is one such good technique. So it is very famous. It is not only applied for images but also in natural languages. And TensorFlow has TensorFlow Hub, which contain all the different types of models, Inception Net, ResNet. You just need to copy the URL and place it in the link, or sometimes even Keras.applications has already the Inception Net, all the famous deep neural network models. You just need to load it. The model will be loaded. You add few layers, whatever you want towards the end, and you retrain it with the limited data set what you have. So that will allow you to get the achieve. That will allow you to get the efficiency with a limited set of data set. Okay, and we have in the next course 3 we have natural language processing. This is about text and processing text. So in course 2 the modality is images, but in course 3 the modality is text, and we would like to predict the next word, and we would like to but basically we try to predict, because it has many applications. You might be knowing, even we write an email, we get recommendations automatically. It automatically suggests the text which you would like to fill. So all those things are possible using natural language processing. And here we discuss some basic techniques. Once again, we learn techniques like tokenization, embedding layer, and we also use recurrent neural networks like LSTMs. So that is in the third week. So both third week and fourth week are almost related, because both are sequences. This is a string is also a sequence, and fourth week is about any sequence, not just string. So the conceptually they are similar. The type of neural network which we use is also similar. Both we don't use tokenization in fourth course, because tokenization is valid only for strings, but for other sequences we use we normally use various other techniques like correlation, various and but towards the end we apply the same LSTMs for building the deep neural network model. So this is about the Coursera course. And this Coursera course contains Coursera specialization contains 4 courses. Within each course there are 4 weeks of assignment, and in total you will be doing 16 graded assignments and 16 quizzes. And if you are able to do this, I think 90% of the preparation is done for the exam. Okay, there are certain few things which we need to remember, especially when we are working in deep neural network. Give me 1 minute. There are few have joined. Yeah. So there are few things which we need to very be careful. Especially you will encounter these things as you move along this Coursera course. You will encounter various loss functions and various activation functions which are used in the last layer. And there are certain times your task would be a multi-label classification, where you need to classify between 10 classes, and there will be a certain times you have only a binary classification. And so it is very important to remember what activation function we use to in the last layer, and what loss function we use. So whenever you have a multi-label classification, we either use categorical cross entropy or sparse categorical cross entropy. So the difference when to use which of these cross entropy depends on whether your output is a vector or a scalar. If it is a vector, especially we call it as a one hot encoded form. What is one hot encoded? Suppose if you have a 10 classes and you suppose the numeral 0, if this numeral 0 is encoded as 1 all zeros, we call it as one hot encoded form. And the numeral 1 0 1 all zeros, so that is a one hot encoded form. So if your output is in the form of one hot encoded, we use categorical underscore cross entropy. So we just put this in double quotes and give it as a parameter when we are building. I'll show few techniques. And multi-label classification with scalar output. If at all you are not, your output is not a probability, or it's not any 10 classes, and your output is simple scalar, but the scalar can be between 0 to 9 or based on the number of classes. If that is the case, if the output is a scalar, then it is a sparse categorical cross entropy. If the output is a vector, then it is a one hot encoded. If the output is a vector, then you have to use categorical cross entropy. So usually whenever we work on the multi-class classification, we use softmax, because softmax gives probabilities as the output. You get because the expression itself is like that, e power z by, I think 1 plus e power z. So if you sum up all the things, you will get 1. So therefore, usually whenever we want probabilities as output or multi-class classification, we use softmax as the activation function in the last layer. I'll show once again with example to make it more clear. And whenever there is a binary classification, we use binary underscore cross entropy with sigmoid as an activation function. So this is a standard thing where sigmoid has two classes. It's a S-shaped curve, and it can take 0 or 1. And we use this activation function in the last layer and this last function. And in the prediction problem, for example, housing price prediction, we use mean squared error. And if you don't mention any activation function, by default it is a linear activation function. And in the time series prediction, especially in the fourth assignment, fourth course, you will be using Huber loss function, which will be mentioned in the ungraded in the videos. And we don't use any activation function because we are not doing a classification. It's not a classification problem, so we don't use any of the standard activation functions like ReLU, sigmoid, softmax. These are all used only when the problem is classification. When it is a prediction, we use a linear activation function, and you don't need to mention it because by default it has a linear activation function. And in terms of metrics, we use accuracy whenever there is a classification, and MEIE stands for mean absolute error. Whenever we use prediction, we try to use this. So this classification is very important because most of the time we get an error and we try to refer to the Stack Overflow for the solution. You have solution for every error which you get. There is a solution in the Stack Overflow. So we just need to carefully search it. So we might encounter this problem. So, but if we are clear about what is the output, if the output is a vector, use categorical cross entropy. If the output is a scalar, you use sparse categorical cross entropy. So that's one of the important choice. And these are important concepts which you'll go through while you do this Coursera specialization, and also very much needed for the certification exam. First and foremost, we should be able to know how do we develop a fully connected neural network. Fully connected neural network is called as dense neural network, or a layer with a simple fully connected network is called as a dense layer. And we should also know the convolutional layer, because and we have conv 1D and conv 2D. Whenever we work on images and if we want to build a CNN, we use conv 2D. So usually what happens is in the first few layers we use convolutional layer, and then we use the dense layer. See, the basic idea behind using convolutional layers is instead of trying to classify the raw images and trying to find out which class it belongs to, what you try to do using convolutional layer is you try to find out the important features from that image by learning the right kernels. So these kernels will learn such that the right patterns are extracted. Instead of taking all the whole of the image, if we just extract the pattern, these patterns are the ones which will help us during classification. Instead of so thereby we avoid the unnecessary content which is there in the image and only look into that important pattern. So Conv 2D makes that job easier. If you just directly give a raw image to a dense layer, there are unnecessary huge amount of unnecessary information which will not allow us to classify properly, but the complexity increases because every image you take a high resolution image, it contains a huge number of pixels, unnecessary pixel, which does not give any valuable information, but that load on the system increases. So Conv 2D minimizes that. So if you see the architecture also, so from the input layer towards the end, as you move along, the size of the image keep on decreases. In fact, the max pooling exactly reduces the size by half. Even the convolutional layer reduces the size. So as you move along the layer by layer, if you stack few convolutional layers, the size of the image decreases and it also extract the important patterns. So and thereby the last few layers, which would be dense layers, the job of the dense layers will become easy because the image size is less and it has only looked down to the specific patterns which will allow us to classify better. So that's the basic difference between dense and convolutional 2D. But in order to truly appreciate this, we definitely need to get a theoretical rigor, like how it is happening, and what is this kernel doing, because convolution is nothing but a filtering. When we apply a filter on a particular image, it extracts the patterns whatever we need it. So we try to learn those kernels in the convolutional neural network, and towards the end there would be few dense layers to classify which class it belongs to. And this concept theoretical background should be there in our mind, and we will be learning callbacks in the second and third assignment in the first course, and we will be learning overfitting in the second course, where we use image data generator. As I was saying, when the data set is limited, in order to avoid the overfitting, we do all these various operations: scale, rotating, shift, shear, zoom, flip, and you don't do manually, but image data generator already has all this functionality. You just need to mention that what sort of scaling you want to do, how much rotation you have to do, and all those, and what percentage of images you want to generate. And you don't even create the directories, training, validation, test directories. There is a method called as flow from directory, which will allow you to quickly create the directories time to time. So you also have a dropout mechanisms. All this, both this image data generator and dropout, will help us to avoid overfitting. Overfitting is one of the one of the big problems. I'll not be going deeper here, but broadly, if we say, if you keep on train with more and more number of epochs, the training error keep on decreases. But if you are testing on a validation data set, the slowly at a beyond a certain point, the error starts increasing. So the point at which the validation error increases is the point where you need to stop the the training. So if you keep on train it, we call it as overfitting, and it is not at all useful because it works for the training example, but for it doesn't work for the new examples. So that theoretical concept of overfitting should be very much needed. And we have transfer learning. As I was saying earlier, transfer learning, TensorFlow contains some of the standard deep neural networks. InceptionNet is one of the famous deep neural network. It is already part of Keras. So you just need to invoke this method. You don't need to even so there are various things. If at all, if it is not part of Keras, you can use TF hub and copy the URL. You will be able to load that model into your program. But if it is, there are some of the standard deep neural networks, very famous deep neural networks like ResNet, InceptionNet. They are already part of Keras. You just need to import that into your models. So which you will also be learning in the course 2 in the specialization. So in NLP, we have tokenizer class. We have a string, but strings cannot be fed to neural networks. You have to convert into numbers, and you don't do manually, but tokenizer and embedding does automatically convert into numbers, and you feed it to the neural networks. But since these are sequences, you don't give it as directly vectors, but you try to use LSTMs. They try to build, so it is a recurrent neural network. So LSTMs are recurrent neural network. it can, and it is very much used for the sequences. So there is a complete specialization or a complete course on sequence models by Andrew Ng, which will help you to master the LSTMs. But a basic understanding of LSTM is more than sufficient for or clearing this specialization, okay, and also this exam. So in and towards the end we have time series. This Coursera specialization discusses about various types of patterns which you have. For example, like the pattern can be a simple linear pattern which we call it as trend. Seasonality indicates periodicity. Suppose if it is a sinusoidal, then how do you try to find out that pattern? Sometimes you also not only have trend seasonality, but you also have noise into it. Now when you have noise, seasonality, trend, what sort of algorithms you use to predict, to make a right prediction? So in the beginning you study with some basic correlation techniques, but slowly you will go into the neural networks and try to use LSTMs. The same thing, whatever we do in the NLP, we use embedding layer as the first layer, and then we use few layers of LSTMs or conv 1D, and towards the end we do use one dense layer, and we build the models. So in total, convolutional neural network and LSTMs and LSTMs for time series, this is what the whole of this Coursera courses contain, and also the exam contains. So mastering these concepts is very much essential for clearing the exam. So but before I go to the other thing, so I would like to say that in total there are only three different ways of creating deep learning models. So sometimes, suppose if you in few assignments there is a one particular pattern of deep learning model is used, usually sequential. I think usually the okay, I think there is one more thing I have. These both these are same. So there is sequential, where you use model dot add to create the sequential model, and there is also sequential using list. Usually we use as a list, but there is also another one which I'll show it to you, and there is a functional way of creating. In some assignments, in the last few assignments, I think they might use functional way. So what is the difference? So here you can see it's a Python list, and each of this layer is separated by comma, which means that it's an element in a list. So this is an input layer. You have a convolutional layer where you have 32 kernels, which is of size 3 cross 3. You give the activation function as ReLU, and you have a max pooling layer. Every layer is a unit in this list. It's an element in the list, so it's just like a Python list. So you are just separated by commas. This is one way. The second way is Python. The second way is actually using sequential, using model dot add, which is not given here because both these are same. So you have model dot add. So you keep on add the new layers, and you stack the layers. That is the second one. And the third one is the functional. This is function. It is called as functional because it looks in the form of y equal to f of x. So you see this is y, and you have some form of a function, and you have towards the end some kind of an input. So usually the previous layer's output will be fed as an input to the next layer. So you have inputs here. This input is fed as an kind of input, and you get layer underscore curve. This layer underscore curve goes to the next layer, and you get layer underscore max. This layer underscore max will go to the next layer. So you keep on feed the previous layer output as an input to the next layer. So this is a functional way of representation. So broadly there are only three different ways. So this is one, this is the second, and third one I did not list here, but that is using model dot add. So you should not get confused if in some certain assignments if they use as a list, in certain assignments if they use as a functional. So this is one important thing to remember. And so usually on the day of exam, you should make sure that before the starting the exam, you should make sure the right environment is set up. This is already there in the setting up the environment. I have all the links which I've given in the towards the end. So Python 3.8, it's very essential. You have to check whether you have installed 3.8 or not. TensorFlow 2.9, and these two are mentioned wrongly in the manual. If we follow the manual, it doesn't work, and we should install the latest version of PyCharm and the latest version of the plugin. Only then it works. So this I got struck because I followed the manual, and it did not work, and it took some time to uninstall completely PyCharm and reinstall once again the new one, and reinstall the TensorFlow plugin. So during the day of exam, I would suggest to use a monitor extension because it's an open book exam and an open internet exam, which means that you can use any manual or any material. So what I have done is, like, I have completed all these 4 courses in the TensorFlow, and I have printed that, and that printed material has helped me a lot during the examination, because you can save a lot of time, because you don't need to bring it from your brain. You can take help of the material because it's an open book exam, and use a monitor extension because you can rely on certain internet sources or your own assignments, Coursera assignments, which will help you during the exam. Use Google Colab. This is very important because your computer might be 8 GB RAM, and my computer was also 8 GB RAM. It took some time to load the model, so it took some time to build the model. If at all, if your RAM is good, it would work more fastly. But Google Colab has already GPUs, so copy the code from the PyCharm and paste it in the Google Colab in one of the and run the model, because what you will be doing during the exam, you will be testing with various type of architectures. Maybe you will be using 64 convolutional 64 kernels, or maybe you will be using 128 units, different layers. You don't know which layer works actually, and you will be heuristically try to put the parameters and try to test it. So in order to achieve the efficiency what it is expected, so you should have multiple systems. In fact, I was also ready with another Windows system, so 2 systems and Google Colabs in both the systems, so that we can run different configurations and see whether it achieves the efficiency or not. If it once achieves, we can use once again finally the same model parameters to get the efficiency. So using Google Colab along with the PyCharm, which is already installed for the exam, is very much useful during the exam. So, and having a laptop with at least 8 GB is very much useful. Less than 8 GB, the time will not be sufficient. It took 4 hours 15 minutes for me with my 8 GB RAM. I did not use Google Colab more efficiently, but Google Colab can be used so that it becomes easier to solve. So that is one thing. And so before starting the exam, we should create the virtual environment. That is very much discussed in this setting up the manual. And it is also important to test whether your environment, everything working fine or not. There are 2 examples, classification and embedding. You just copy the code and run it and see if you are getting any error. If there is no error, then it is very much ready for the exam. And so as I was saying, so it took around 4 hours 50 minutes. So first 2 problems are very easy. They are exactly from this Coursera course. You would be able to do it in within half an hour or 40 minutes. But the third question, it takes time. So if you carefully choose the model parameters to achieve the desired accuracy, in a single shot you might get the right answer. But if you're not able to get the right answer, it will say that okay, 2 test cases has passed but not the other. So in the beginning I got the same, only 2 test cases has passed. The first 2 problems, all the 5 cases have been passed. So the third one, only 2 test cases passed. So I kept that aside and went to the 4th problem, and I was working on that, and their 4 test cases has passed. And in the meantime, I was putting in another system to run for a different configuration. So having multiple computers and Google Colab will help you to know which model parameters will work for the problem, and it is important to do parallelly so that you can save a lot of time. And fifth problem, as I got stuck with it, it took some time. It went until the last few minutes to get the answer. So Google search, you can do the Google search for the exact problem. Sometimes you might get help from Google. Stack Overflow is one place where you can get help. I would not say easy, I would not say it is hard, but it is a medium level exam. But doing this Coursera specialization is very important before you attempt this exam. So it took me around 4 hours 50 minutes to complete the exam. So there were like few models. The fourth and the third and fourth question, there were only 4 test cases as passed, but I kept it. So we should not, whatever is the last final model which you have developed, it will consider that for evaluation. So if you don't do anything, it will automatically take and submit and test the test cases and give the scores. So I don't know exactly the pass mark for this. There are, I think it allows for certain one or two test cases to go by wrong. Also, there is nothing. It allows you, after clearing the certification, you will get this mail that you have passed the exam. You will also get the certificate. If you register in this form, your name will also be appeared in this TensorFlow developer website and the community, and it shows from when to when it is valid. All those things will also be there. So important links are the candidate handbook. This is there in your TensorFlow exam. It gives you the syllabus. So I'll show what is the syllabus. So I have a set of links. So for example, so this is a TensorFlow developer certificate handbook which is there. So it clearly discusses the what all things it expects. So exactly the syllabus matches with the Coursera syllabus for image classification, natural language processing. This is the exam syllabus, time series sequence prediction. So exactly this thing. So it gives a lot of information here where to attend the exam URL link, and also eligibility, fees. So the cost of this exam is $100. How many times you can attempt, where can you see the result, all this information. It is very important to go through this handbook before we attempt the exam. And also there is another link which is setting up the TensorFlow environment. So which version of PyCharm, which version of plugin should be installed, all those things are mentioned very clearly in this setting up the environment. So these are some important links. And Coursera specialization, it's very important. Plugin link, you can go to this link, you will be able to get the plugin. So I'll just show it to you how the, okay. So this is the marketplace TensorFlow developer certificate. So the manual gives a wrong thing, which I'll try to show it to you, because this is where we get stuck. You can see here it says TensorFlow 2.7, Python is 3.8, but it says to install 2021.3, but plugin has some error with it can't install. So 2022, it worked for me 2022. You can see here, this is the plugin which is active, and it works only with the PyCharm 2022.2. So that we have to be little careful. And apart from that, this is the link. You can get this link for the exam in the handbook. And these are some links where people have shared their experience of how they have cleared the TensorFlow developer exam. And that's it. So this is a short description about how to clear this exam. I hope this is helpful to you, and if there is any questions, I would like to listen.